Let me share with you a beautiful question from one of our subscribers. It is based on IB test paper. We are going to analyze the derivative, find maximum and minimum, decreasing interval, and then the equation of the tangent line. Enjoy the journey of learning. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up a test question from IB test paper. Let us see how do we solve this in steps. Starting with 1a, which is consider the graph of the function f of x equals to x cubed plus 2x squared minus 5. Label the local maximum as a on the graph. So as you can see, the turning point here is the local maximum a. Part B is label the local minimum as b. So that seems to be the local minimum at b. C. Write down the interval where the derivative is less than 0. So let's find the derivative of the function. So we have f prime x equals to 3x squared plus 4x, applying the power rule. You can factor this taking x common. So we have 3x plus 4. 4x common, correct? So we have 3x plus 4. So clearly, critical numbers are at which point? So we can now find the critical numbers, which will be when the first derivative is equal to 0. So in this case, first derivative is 0 when 4x is equal to 0 or when 3x plus 4 equals to 0. That gives you the value of x as 0 or x equals to minus 4 divided by 3. So we got two critical numbers. We really need to find the interval where the derivative is less than 0, means negative. So now let's try to analyze this. So we'll use interval table. We have two zeros, one at minus 4 by 3 and the other at 0. So let us take test points in these intervals. Less than minus 4 by 3, we could take this as minus 2. Between this, we could take as minus 1. And here we could take 1 as our point. Now, the factors are 4x and 3x plus 4. So if you check the value of 4x, at minus we get negative, negative, and that will be positive. For 3x plus 4, negative 2 will give me negative value. However, minus 1 will give me positive, 1 of course will be positive. So from here, we can find what the derivative sign is going to be. It is going to be positive in the interval less than minus 4 by 3, negative in the interval between minus 4 by 3 and 0, and positive after 0. Since we are interested in finding where it is less than 0, so clearly we have our interval which is between minus 4 by 3 and 0. So that is the interval where the derivative is negative. On the graph, you can see it is between A and B, right? So we also figured out that the point A, the x value here, is minus 4 by 3, and B is at 0, is a y-intercept, correct? So that is the interval in which we have the first derivative as less than 0. That means the function is decreasing, right? Perfect. Now, part D is draw the tangent to the curve at x equals to 1 on the graph. So, you can see that 5 is here, and we can find the x-intercept and then draw the tangent, right? So, we'll do it on a fresh page. So, we have done part 1a and b and c. Now, we are looking into this. 1d is to draw tangent to the curve at x equals to 1 on the graph. And second is write down the equation of tangent at x equals to 1, right? So let's find the value of the function at x equals to 1. So what is f of 1 equals to? If I substitute, I get 1 cube plus 2 times 1 square minus 5, which is 1 plus 2 minus 5, which is minus 2. So at 1, we get a point which is kind of shown here, right? And if I draw a tangent here, how will it look like? So let me just draw a rough tangent here. So that could be the tangent. Let me redraw, right? Touching, there we go. So we'll assume this is like touching the graph at a point which is 1 minus 2, right? It is in quadrant 4. Now, part E is write down the equation of tangent at x equals to 1. So for equation of tangent, you need slope also, right? So the gradient, as we worked out earlier, is 3x squared plus 4x. Now add 1, it'll be 3 times 1 square plus 4 times 1, which is 3 plus 4 or 7. So the gradient here is 7, right? Now the equation of the line will be y equals to mx plus b. So, and you can also use slope-intercept form. So let me use slope-intercept form to write down the equation, which is y minus y1 equals to m times x minus x1. Correct? So y minus, the y point here is minus 2. Slope given to us is 7, right? X minus 1, correct? So that is the equation. We have y minus 2 equals to 7x minus 7. Let's rearrange. We can write down this as 0 equals to 7x, taking y to this side, minus y, and minus 7 minus 2. And that gives us 7x minus y minus 9. Or you can also write this as 7x minus y minus 9 equal to 0. If you wanted to write it in slope-intercept form, this is the standard form, right? In that case, y will be 7x minus 9, right? So that becomes the equation of the line. That means this y-intercept here for the tangent should have been minus 9. Make sense? So that becomes the tangent and its equation. So I hope the solution of this question is absolutely clear. Perfect? Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Also, if you can, support your channel. We provide solutions to your questions absolutely free, and we are doing it for the last 15 years. All the best and have a great day.